Okay, the next section, part 3. Part 3 is just naming these guys, and this is super easy. You've been familiar with this for years already. You know that NaCl is sodium chloride. You know that you write the first word or say the first word just like it is, and then you change the ending of the second word to "ide." So this one would be magnesium chloride. Skipping around a little here. This is potassium. And then sulfur gets changed to sulfide. Lithium and phosphorus, I'll just give you a heads up. Phosphide. This is nitride. Nitrogen gets changed to nitride. So it's always an "ide" ending on the second word. First word's just your metal, say it like normal. Iodine gets changed to iodide. Now, I'll be pretty lenient with you in the beginning because you need a while to kind of become familiar with these endings. But some of them I expect you know, bromide, oxide, fluoride, and so forth. Some of them you're going to take a little time to learn and know what sounds correct just from experience. So do your best on that. We'll go over them, you'll get used to them, and then you'll be naming these like a pro. All right, next section. It asks you to build a little bit, and it introduces, build on concepts, I should say, and it asks you to use a new crisscross method here of writing formulas. Now, the first one's easy. You know, hopefully, sodium makes a +1 charge. It's in group 1, gives away 1. Chlorine's in group 7, it gives away 1. Or it gets 1, rather. You know that the 1-to-1 ratio creates an NaCl formula. And we know that that's sodium. We write the name of the metal by itself. And chlorine gets changed to chloride. So that's easy. Now let's make it trickier. Here's aluminum. Aluminum's in group 3. It ends in S2P1. So it's got 3 electrons it wants to get rid of. Bromine over here in group 7 wants to get 1. Now if aluminum tries to give all 3 electrons to bromine, bromine's going to say, wait, I can't do that. I can't accept all 3. I can only take 1. But there's a lot of bromines in the container. I can go find some of my friends, and each one of my friends will take 1 of your electrons till you're all set. So it just so happens, and I'll draw it up here, that one aluminum with its 3 electrons hooks up with 1, 2, 3 bromines. So it's going to be an AlBr3 ratio. Now here's the crisscross method. You take the charge, without the symbol, so just the 3, and you put it down here. And you take the 1 without the symbol, and you put it down here. And you rewrite it AlBr3, which is what you get when we did it through the thinking process. Just reasoning it out. Aluminum giving rid of electrons, bromine taking electrons, and then figuring out what ratio. So there's aluminum bromide. And then again, it's aluminum bromide. Let's look at aluminum and oxygen. Here's aluminum with a +3 charge. Here's oxygen saying I can only take 2. So if aluminum tries to give all 3 to oxygen, that won't happen. Aluminum can give 2 of its electrons to oxygen, make oxygen happy, but then aluminum's not happy because it's still got 1 extra electron. So they're going to have to go back and forth and find a bunch of friends and settle it all out. Now, if you just use the crisscross method, it's very easy. Take the 3, put it down here, take the 2, put it down here, and you end up with Al2O3, aluminum oxide. So the crisscross method comes in handy. Let me show you this. This was the aluminum oxide that you had to reason out. Hopefully you did this already. But you would have realized that, hold on 1 second. Okay, you would have realized that aluminum can give away 2 electrons up here. This one's all set with its -2 charge. This aluminum's not happy, still has 1 more to give, but it can't give it to the first top oxygen anymore. Now it can give it over here. Now this aluminum's all happy. It lost 3 electrons, but this oxygen's not happy. It only gained 1, it needs to gain 2, so it's going to look at another aluminum. Here comes your other aluminum. Now that's happy, it's gained its 2, it's got 8. This aluminum's not happy, so it's going to come over here. 1 there to that oxygen, 1 to that oxygen. This oxygen's all set, -2. This aluminum's all set, +3. Add up the sum, just to make sure we're right. +6, -2, -2, -2, -6. These two are equal, and we're good. So that's why we can end up using the crisscross method. You can do it that way, or you should be able to do it that way. You should be able to explain. Or you could just do this crisscross. Take the 3, put it down there, take the 2 from the oxygen, put it in front of the aluminum, and you end up with the same exact thing we get when reasoning. Now, one quick catch. When you have two things, for instance, magnesium, magnesium's +2, sulfur's -2. When the numbers are the same, they cancel each other out, and it's just a 1-to-1 ratio, MgS, magnesium sulfide. You don't have to crisscross them. I should never see Mg2S2. If the numbers are the same, they cancel each other out. All right, next section. All right, this is talking about the D block guys and some of the lower P ones underneath the stair step. Some of these elements do not follow the rules, and you have to either memorize the charges, you have to look them up, or you can determine what the charges are from the formula if you're given a formula or even a name of a compound. But either way, you're going to have to do some figuring out on these guys. So let's look at this table. Some of them you're given the cations, anions, some you're given the formula, some you're given the names. Let's work forward and backwards. Now before we do that, let's talk about Roman numerals real quick because they come in handy. You need to know some basic Roman numerals. 1, 2, 3. That's the highest you go in terms of putting consecutive letters. 5 is a V. 4 is a V with an I before it. If you put a letter before it, it means subtract. And then if we keep going, put a letter in front of it, it means add. So this is 6, not that you need all these, 7, and so forth. Alright, so we're going to need basically 1 through 4, maybe 5 here and there. Alright, iron. Iron's got a +2 charge. Over here, iron's got a +3 charge. And they're both hooking up with chlorine. And chlorine's a good old representative element. Remember, representative elements are S and P block. They make things easy for us because they follow the rules. So here's iron hooking up with chlorine. Iron's going to be taking the 1 from the chlorine. We don't have to draw it in, it's imaginary. Chlorine's going to take the 2 from the iron, and it's going to be iron, and I'm purposely leaving a big space here, and I'm going to write chloride. This one, iron's a +3, chlorine's still a -1, chlorine will always be a -1. So we get iron with the imaginary 1, chlorine, but this time it's Cl3 instead of Cl2. We call this iron chloride. And if I left it like that, and I said that this is iron chloride and this is iron chloride, I would have a problem. Because the two formulas are two entirely different formulas, they're hooking up on different ratios, and that makes a big difference. So I need to indicate which iron this is. Is it the +2 or the +3? And I'm going to do that with Roman numerals. Now your Roman numerals tell you the charge of your metal. The Roman numerals tell you the charge of your metal, not how many are in the formula. If we used how many are in the formula, that'd be silly. This is 1, this is 1. We wouldn't put 1 in each and then say they're two different names. It's not, kids make this mistake constantly, which is why I'm stressing it, not the number of cations in the formula. It's the charge. Charge of your metal. Okay, so iron in this case makes a +2 charge. Over here makes a +3 charge. So like right away, if I look at this, I know lead makes a +4, and I know this lead makes a +2. That makes my life super easy. You like to see Roman numerals and names because you don't have to do any thinking.